In this example, we want to show that the inner product on two functions, f and g, which are both continuous and differentiable on 0, 1, is in fact an inner product. So it satisfies the four properties. So property 1 is that the inner product of f in itself is greater or equal to 0, and it's equal to 0 only when f is the 0 function. So this would tell us then that the inner product of f with itself is the integral from 0 to 1 of f of x, so f of x squared, plus f prime of x, so f prime of x squared, so this inner product, if we look at it, if f is different from 0, let's even backtrack a sec. Whatever f is, f of x squared is greater or equal to 0. Whatever f is, f prime of x squared is greater or equal to 0. So this thing has to be greater or equal to 0. Now, the only time this thing is ever equal to 0 is if both f and f prime are 0. Well, if f has to be 0, that forces f prime to be 0. And so the inner product of f with itself equals 0 only when f is 0. So property 1 is satisfied. Next property, property 2, is that the inner product of f plus g with h is greater or equal to 0. Sorry, not greater or equal to 0. I don't know what I'm talking about here. It's equal to the inner product of f with h plus g with h. We're sleeping for a minute. Okay, so let's try and prove that. The inner product of f plus g with h is equal to the integral from 0 to 1 of f of x plus g of x times h of x plus the first thing, the derivative of the first thing. So the derivative of f plus g is f prime plus g prime times the derivative of the second thing, so h prime. Now we can go ahead and distribute the h of x into these brackets and the h prime into these brackets, and we'll get, if we repackage it, we can get the integral from 0 to 1 of f of x, h of x, plus from here, f prime of x, h prime of x, dx, plus the integral from 0 to 1 of g of x, h of x, plus g prime of x, h prime of x, dx, which makes this guy the inner product of f with h, and the second guy the inner product of g with h. So we have the second property satisfied. Thirdly, we want to show that the inner product of alpha f with g is equal to alpha times the inner product of f with g. Well, the inner product of alpha f with g is equal to the integral from 0 to 1 of alpha f of x, g of x, plus alpha f prime of x, g prime of x, dx, which we can rewrite, pulling the alpha out from both terms as alpha times the integral from 0 to 1 f of x g of x plus f prime of x g prime of x dx. So that's alpha times the inner product of f with g. Finally, we want to show that the inner product of f and g is equal to the inner product of g with f. Again, we're talking about inner products on real spaces here. So the inner product of f and g is equal to the integral from 0 to 1 f of x g of x plus f prime of x g prime of x dx. But we can reverse the order of these products. So this is the integral from 0 to 1 g of x f of x plus g prime of x f prime of x dx, which is indeed the inner product of g with f. And so because all four properties are satisfied, this is in fact an inner product that we're giving here.